In this video, we're going to talk about the unit circle. So we talked before about measuring angles with degrees and radians. Let me just draw the 0 degree line here. That's 0 degrees. And when I measure angles, I'm going to use t to measure these angles. So this is 0 degrees or 0 radians. If we go a quarter of the way around the circle, that is 90 degrees or pi over 2 radians. Halfway around the circle, that's 180 degrees or pi radians. 3/4 of the way around the circle is 270 degrees or 3 pi over 2. You could think of pi over 2 as being a quarter of the way around the circle, and then you do 3/4 to get to 3 pi over 2. All right, so those are the kind of easiest angles. And then we can take these angles and we can split them, so we can look at half of 90 degrees, which is 45 degrees. So this is 45 degrees or half of pi over 2, which is pi over 4 radians. And then we have halfway between pi over 2 and pi. So what is this angle? So 90 and 180, it's halfway between 90 and 180. 90 to 180, that's a 90 degree difference, and half of 90 is 45. So 90 plus 45 is 135. If we do this angle in radians, it's pi over 2 plus pi over 2 divided by 2, or pi over 4. And if we create a common denominator, then we're going to get 3 pi over 4 as our angle measurement here. So this is 135 degrees or 3 pi over 4. Okay, and then I'll just give you the other two real quick here. This is 225 degrees or 5 pi over 4. And this is 315 or 7 pi over 4. All right, so now that we have these angles in the unit circle, we're going to put the coordinates of the points on the unit circle at these various angles. So we have this point, this point, this point, and this point. And then we have these 4 points, which I'm making in red. So if this is a unit circle, it has radius 1. The coordinate of this first point on the right here, this is 1, 0. And the point opposite it on the circle is -1, 0. And then the point at the top here is 0, 1. It's 1 up in the y direction and 0 in the x direction. And the point at the bottom here is 0, -1. All right, those are the easiest. The point corresponding to 45 degrees, that's 1 over root 2, 1 over root 2. Why is that the case? Well, if you make a little right triangle here, let's extract this right triangle. We know that the hypotenuse is 1, and I'll call this x, and because it's 45 degrees, this is also x. And we know x squared plus x squared is 1 by the Pythagorean theorem. So we have 2x squared equals 1, or x squared equals 1/2. And if we take the square root, we get the square root of 1/2, or 1 over the square root of 2. Now sometimes people like to rationalize the denominator and write this as square root of 2 over 2. I'm okay having an irrational denominator and just writing this as 1 over root 2, 1 over root 2. All right, so now the point corresponding to 135, it's symmetric. So it's going to have the same y value. It's just as high as the point we just did, but it has a negative x value. So it's going to be -1 over root 2, 1 over root 2. In a similar fashion, we can figure out these other 2 points, 225 and 315. They're going to be -1 over root 2, -1 over root 2, and 1 over root 2, -1 over root 2. All right, so we have another set of points to do. It's going to get a little cluttered here, but we're going to do 30 degrees, which is right about there. 30 degrees is pi over 6. And we're going to do 60 degrees, which is right about there. So this is 60 degrees or pi over 3. All right, let's figure out the endpoints here. So if we extract this right triangle here, we have a 30 degree, a 90 degree, and a 60 degree here. And if we copy another one of them here, this is going to be 60 degrees, 30 degrees, and 90 degrees. And this is, if we put these two triangles together, we get an equilateral triangle. So this is one, this is one, this is one. 60, 60, 60 degrees, 1, 1, 1. So we know, because it's equilateral, that this distance is a half. So the y-coordinate of this point is a half. And if we know that the height is a half, we can then use Pythagorean theorem to figure out the width. So for this 30-degree triangle, we know the hypotenuse is 1. So let's figure out the unknown side. We'll call it x. So I'll have x squared plus a half squared equals 1 squared. Half squared is 1/4. 1 minus a fourth is 3/4. And so x is going to be the square root of 3/4, or the square root of 3 over 2. So the x-coordinate of this point is the square root of 3 over 2. So if that's the 30-degree point's coordinates, I claim that the 60 degrees point's coordinates are going to be 1/2 root 3 over 2. And you might have to think about this a little bit, but maybe spend a minute, if you're curious about why this is true, spend a minute thinking about the geometry of the 60 degree and how it relates to the geometry of the 30 degree. All right, so now we can do more points on the left here. This is t equals 120 degrees, or 2 pi over 3 radians. And we also have t equals 150 degrees, or 5 pi over 6 radians. And these we can figure out by negating the corresponding x value. So we'll get, and then if we negate the y-coordinates of all these green points, we'll fill in the bottom half of the circle. Let me do that really quickly. All right, so that's the bottom half. And now to go from 150 to this other angle here, I'm going to have to add 60 degrees. It's 30 degrees to the horizontal and then another 30 degrees. So 150 degrees plus 60 degrees, that's 210. So this is 210 degrees. And if I do this in radians, I'm going to have 5 pi over 6 plus pi over 3. Pi over 3 is 2 pi over 6. So that's going to be 7 pi over 6. So you can use that argument to figure out that angle. To go from that angle to the next angle, I'm going to have to add 30 degrees, because 120 to 150 is 30 degrees, so 210 to the next angle is going to be another 30 degrees. So that's 240 degrees, and that's going to be another pi over 6 that we add. So that's 8 pi over 6, which is 4 pi over 3. And then to get to this next point, I'm going to have to add 60 degrees, so I'll get 300 degrees. 60 degrees is pi over 3, so I'm going to add another pi over 3. So this will be 5 pi over 3 from 4 pi over 3. And then to go to the next, I'm going to add 30 degrees, so I'll get 330 degrees. I'm going to add a pi over 6. 5 pi over 3 plus pi over 6 is 10 pi over 6 plus pi over 6, which is 11 pi over 6. So this is 11 pi over 6. These are kind of funny angles in radians and in degrees. Okay, so this is the complete unit circle. Let me clean this up a little bit. If we look at the plane here, positive x and positive y, that's called quadrant 1. Quadrant 2, going counterclockwise, is positive y, negative x, and then quadrant 3, and then quadrant 4. So really we only need to know quadrant 1, and all the other values you can figure out by symmetry. So even though this is a very intimidating diagram, if we really memorize just these values here, then we can get the rest by symmetry. In fact, you don't even need to know these two. The second guy can get you the fourth value by switching the x and y. By negating, you can go across. Negating the x value, you go across horizontally. Negating the y value, you go across vertically. And then negating both the x and y values to get you over here. So one green value can get you all the other green values. one purple value can get you all the other purple values, and one red value can get you all the other red values. So the symmetry really helps in memorizing the coordinates. In fact, I only memorize these three, and then I get the others based on symmetry. I hope that helps.